Hey, GS112, we are about to start a topic that always makes students' hearts go pitter patter, and that is math and statistics in science. So, one of the things that I'll hopefully do is hopefully I'll take these incredibly boring PowerPoint slides and kind of show you by actually doing something close to what a scientist would actually do on a certain data set so that you can kind of get a little bit of an idea of what all these kind of mathematical expressions that we're about to talk about are really used for, and the idea that they actually can be useful, even though when I know I was first introduced to them in statistics, I was like, why are we doing all this? So anyway, I just have like a couple of silly examples that we're going to take a look at for a data set that was painstakingly researched, let's just say. So bear with me. One of the things I did want to mention is that this topic is a little bit more heady than some of the other stuff that we've done so far. So what I'm probably going to do is kind of spread this out over the course of like 2 weeks. So instead of just trying to cram everything in like the 2 days we have remaining here in this lecture week, this will probably bleed a little bit into next week as well, just to hopefully make sure that you guys are all on the same page. As always, get after me at office hours. That happens Monday and Wednesday, and also Friday. Monday and Wednesday have a morning and an evening session, and then Friday has just a morning session. Or a lot of people have just been communicating to me on Canvas, which also works. All right. Say hi to my buddy over here. Hump? What hump?
Bingo. In. Now the object is to get the cork out of the bottle any way you want. You could try to put water in there if you want to. You just say you got to get the cork out of the bottle, and you can't destroy the cork, so it can't come out in a million pieces. You can't light it on fire inside the bottle. You need to get the cork out of the bottle. Well, here is one way to do it. Believe it or not, it's as simple as using a produce bag from the grocery store. You want to put the bag into the bottle and blow a little air into it. So how can a plastic bag help you get the cork out? Well, you've got to just turn the whole thing upside down, right? So a little creativity. Now put the cork into the side of the plastic bag. Then we're going to use friction to help us a little bit grab onto the cork, and then we don't want that friction. We want the bag to actually slide through. So we're going to try to pull this back through. See if it can catch. Come on, catch. There it is. Oh, perfect. See how it caught? There at the very, very end. So now when we pull like this, the cork comes along with the plastic bag. There's enough friction between the cork and the bag to stay there, but the bag against the glass is kind of wrapped around the cork, and now it's going to take a little patience. You can do it. You just don't want to break the bag, but they are incredibly strong, and
All right, party people, here goes nothing. So we are talking about statistics. We mostly talked about measurements last week, but an important part of being able to record a whole bunch of measurements is knowing what to do with all of the bazillions of measurements that you record. So this is what's called statistical analysis, which I'm sure you're pretty excited about. And the whole idea is, in science, is that you repeat measurements 8 bazillion times. And then you hope to kind of narrow down a bunch of different factors. For one, you just want to like kind of narrow down your accuracy as best you can. And there's a whole bunch of different concepts that we're going to be talking about. Some of them are used to treat like particular data sets to kind of get trends. Other things are going to allow you to assess like more complex things, like is something truly caused by another thing, or is it just some sort of correlation? So anyway, I just wanted to give you a little bit of insight into all these things. So as I promised I would include something a little bit silly to hopefully liven this thing up a little bit. So I'm just going to switch my screen over to an Excel file, which I'm sure you're excited about. So here is something called Microsoft Excel. This is just basically a statistics program that Microsoft puts out. Of course, there's 8 bazillion of these. I don't necessarily use this all the time, but it's probably the easiest thing to kind of show you some of the things that different spreadsheet programs can do. So obviously, we got to make sure that we look at something interesting. So what we're going to look at is a statistical analysis of mullets. We're going to answer a lot of your scientific questions through this survey. As I said, I painstakingly recorded these results, which means I made them up completely. But we will kind of ignore that little part there. And so what you can see in this, as we just kind of pan through, is that already we can see that we surveyed a whole bunch of individuals and we tried to determine a couple of things about those individuals that had mullets. So all of our concepts are going to be kind of according to this. One of the things that I should show you about a spreadsheet program, and the reason it's really useful to any scientist, is that you can kind of program in certain functions. One of the things you'll notice is this little function right here. So all you do is you click on a particular box and you'll notice that it has an equal sign, and then there's some sort of command, which is me giving a command to the computer to do something I want it to do. Conform, computer! And so in this particular line right here is a really simple formula here. I'm just basically summing up these two areas right here. And so one thing, if you want to kind of go back and kind of reverse engineer these silly things that I'm doing here, each one of these boxes has like a column and a row number. So this one is considered E4 and that one's E5. So the advantage of this is that, like, you know, if let's say I recorded another 55 individuals that were male, what I could do is, instead of like having to like recalculate everything myself, what I can do is I can change that particular number, and then what you'll notice is, if you were looking carefully, is the percent of mulleted males, changed when I changed that number. So that particular cell is kind of included in a whole bunch of different calculations. So this is kind of something that the first time I was showed this, before I was showed how to use a spreadsheet program like this, I literally would get out my TI-84 and like calculate all these different things, like 100 different examples of data. And then I would, somebody would change something. I'd be like, oh, great, I got to go back and calculate everything. So this is just a really useful way to just kind of have these little, programs written in these little boxes to do various things. And of course, like, I am not an expert in Excel, and there's all kinds of really fancy things you could do that the physicist knows a whole bunch about. But, if you're ever interested in designing some sort of silly Excel sheet, I kind of know how the basics work out. And of course, like, you can graph using this, and we probably will do that either in our lab or in the future. But as with anything computational, it's a huge pain in the butt and takes you, a bunch of time. At least for me, it takes a bunch of time to learn how to do anything new. So anyway, don't worry about that too much. So let's get back to our presentation. So when you look at statistics, there's a whole bunch of different variables. We'll just talk about some of the most basic ones, the ones you kind of need to understand the way that science is done. So we've already talked a little bit about measurement uncertainty. This kind of gets at that idea of precision, right? That idea that we use certain instruments with certain amount of precision, and we can communicate that precision by what numbers we used, right? And so we learned this rule of like how many decimal points you use kind of communicates a little bit about precision. And so that, in a sense, is measurement uncertainty, but also you'll often include like a plus minus value due to the precision of the device. So if we just kind of switch back real quick to our PowerPoint file, we've got this column right here. Hopefully you can see my cursor. And what we have is the measurement uncertainty that's actually printed out right next to these various values. And this is just the length of various mulleted individuals, like how big is their, or how long is their mullet. And so, like, you can see here, for instance, like this guy has a monster mullet. Male mullet number 8 is the man. So he's got a 54 centimeter mullet. For whatever reason, the device that we used to measure that mullet was much more precise than, let's say, this poor pathetic person that only had a 9.3 centimeter mullet, right? His plus minus was like 0.2. So that's something you want to keep in mind, that, the measurement device can be kind of indicated both with the number of decimals and also with the actual plus minus that you call a measurement uncertainty. Another pretty important thing to consider when you're doing statistics is the sample size. One of the things that's really obnoxious about statistics is that they all have these different, letters which represent them. So if you happen to see some silly scientific study that I'm forcing you to read in the future, and you see this big giant N, that's usually an indication of sample size. And really, to define this, it's super simple, right? The number of data points investigated or the number of people in the study. So if I kind of go back to my PowerPoint here, you notice the sample size information. So you'll notice right here where it says total surveyed. So I painstakingly interviewed and measured 900 people right here, half and half, male and female. And then I also kind of did like a sub study here where I measured exactly how many had mullets, right? So of the males, I've got 46 out of that 450, and then I have 6 females with a mullet. But the important thing, and I mean, I had to, include this. Obviously, the mulleted individuals that were reported by resounding response from the rest of the participants as being sexy were 47, right? And so I mean, look at your percent sexiness with the mullet, right? You're not only guaranteed to be sexy with a mullet, but you're more than guaranteed, right? 102%. Obviously, these are very hard numbers. I would trust everything that you see here today. Interestingly enough, you're even more likely to have when you are a mulleted female, you're even more likely to be considered sexy. 133% of those. So this kind of indicates two different things, right? We see this thing called a sample size, or our N is 900 in this case. But then you can also kind of have little n's, right? You can have the 450 female participants and the 450 male participants. So it's quite often that you have kind of different samples that have a capital N is the whole entire sample, small n is the some particular small subset of individuals. So this next idea of frequency, we've kind of seen this already by the percent sexiness and also the percentage of males with mullets and females with mullets, right? And this is something that is reported in a bunch of different ways. I just chose to report frequencies for some particular trait in percentages. Sometimes you'll see them as fractions, sometimes you'll see them as actual numbers, sometimes they'll be graphed out, right? And so that's all that I mean by frequency. So these are kind of the core concepts to understanding statistics. And what we're going to do now is we're just going to look at 3 or maybe even 4 different kind of more specific ways of looking at data. And again, if any of you have had a statistics class before, this is all going to seem like a lot of review and kind of silly. But for those of us that have no background in statistics, it might be kind of nice to see the way some different things are done. So one thing we could look at is called the median. It's abbreviated MDN, quite obvious, quite simple to kind of see that, right? There's no Greek letter or anything. Kind of makes sense. And what this is actually the middle value when numbers are all written in order from lowest to highest. This used to be a huge pain back in the days before computers, and I would like to say that I maybe am young enough to have always used computers, but this is not the case. What you'd have to do for this is actually write all of your data out from kind of the lowest number to the highest number, and then the one that ends up being like smack dab in the middle, right? If you have like, well, we'll see in just a second here. If we have 25 entries, the one that is halfway through is number 13, right? And so that one's called a median. Let's kind of see how to do that on an Excel file. So here we've got all of our mulleted males. One of the things you'll notice is that we only had time to measure the mullets of 25 of our 46 mulleted males. So this is incomplete information. So if you want to go on and do a study in your community, please feel free. So one of the really easy ways of kind of going to figure out a lot of these things without spending all that time listing them in order, right? Like who wants to take all these mullet lengths and put them in order? What you can do is you can just enter a little formula, which as long as you put an equal sign, this computer will recognize, okay, in this box I'm going to do some sort of calculation. And super simple, if I think I remember this, is you just have to type median parentheses to let you know what you want to take the median of, and you simply put the first value that you want to, or sorry, the first bit of data that you want to look at, and then a little colon, and then you go all the way to the end. And you'll notice that as it's written now, it's all color coded, and I know that what's going to appear in this box right now when I close the parentheses and press enter is the median value, right? So it turns out if I were to take all these values and list them off, lowest, highest, our median right there, and let's just put the abbreviation next to it, right, is written right there. So 15.5 centimeters would be the median mullet length in our study. I can hear you all screaming for more things to do on Microsoft Excel, so let's keep going. Another really common thing is called the mode. This one's pretty easy as well. This is the most common value, right? So in other words, if there's one that happens to repeat a whole bunch of times, the mode function is going to allow you to kind of pick that one out. So in my list of 25 different mullet lengths here, let's say that I want to figure out what the mode is, in other words, the most common thing. Well, surprise, surprise, what we're going to do is click mode, do that exact same thing that we just did, close the parentheses, we'll check the expression to make sure all is well, and then, hey, lo and behold, the most common one happens to be the median itself. And hopefully that is actually the case. Do you see a whole bunch? Yep, I see a bunch of different 15.5s. So that is good news. So our mode, which is usually abbreviated with MO, is 15.5 along with our median. Woohoo! Okay, so we got mode. Not surprisingly, there's also something called a range, and this kind of gives you an idea of the total spread of some set of data, right? All it is the difference between the maximum and minimum values. In terms of reporting this, I've seen some reports that'll say my minimum was this and my maximum was that. Sometimes they'll subtract the two, and so I'll kind of show you that on Excel. So sometimes it's not as simple as just typing equals and then some sort of command. So this one you got to get a little bit creative about. So we're going to do equals, and there is a function that I know about that allows you to find the maximum in a particular data set. So let's do this one. And so let's see, that is B36 that I want to go to, right? And then, so as it is right now, if I were to press enter right now, it would just list off the maximum value, which, you can certainly do. So here, oops, that's not actually a range though, that's the max value. And then there's another one where you can determine the minimum value. Same kind of setup here. Would you all please calm down? You're getting a little too loud and excited about this. All right, so we've got, oh man, I feel bad for that guy's got such a small mullet. That's okay, he's still sexy according to the data. So anyway, that's kind of one way you can list the range. Another thing, if you really wanted to list the range in a subtraction form, it's pretty easy. All you have to do is say equal this cell minus that cell. And then you can see that the range, at least in terms of subtraction, is 52.8 centimeters. So all kinds of different things that we can set this program up to do. Let's do one more, and then we'll go to the discrepant event. Guarantee you that you've done a mean before, but you might not have heard it called a mean. It is also called an average. Just to really impress Grandma now, I'm going to show you that you can use this Greek letter called mu, which looks kind of like a cursive U with a tail, right? So that's a lowercase Greek letter called a mu. What's mu with you? I've been on quarantine for too long. So anyway, what the heck does it mean? Well, thank you for asking. It's the average of all the values. And usually with a mean, you also report some sort of uncertainty. I should mention that if you're like in Mary Stinnett's class, I think she differentiates between something called a sample mean and also a population mean. So I think this is actually technically the sample mean abbreviation, and then like the full population mean would be an X with a bar over it. But don't tell her that I don't care, but shh, keep that quiet, okay? So there's all kinds of different bells and whistles here. The mean is actually super easy to do with Excel too. You all have probably calculated an average before. So basically what you probably did in the past is you take all of these values, add them all up, and then divide by 25, right? Because that's the total number that I have, the big N. Luckily, we don't have to do that. But keep in mind, usually you're not using a list of 25, but oftentimes you're using like a list of like 100,000 entries, and you definitely don't want to do that. So, of course, we can also do this. We can type equals average. Same exact kind of idea. To, what did I say, 36. And that gives us an average. And, I did say that you're supposed to report measurement uncertainty. There are rules for how you're supposed to do that. We're just going to say, let's say plus or minus, and then we'll just average up the measurement uncertainty. Don't tell Mary that I'm doing this, by the way. She'll yell at me. But it's just easy enough to do this. And let's see, then I have to go to C36 and to, C36. So plus or minus 0.126, which gives you an idea of the precision. Yes, I know there's like actual mathematical ways of doing that, but let's just make it easy on ourselves, right? And so this thing right here, 16.8 plus or minus 0.126, this thing is considered the mean. Or I don't know how to, well, yeah, I'm not going to bother making a Greek mu on this thing. Well, maybe I will since I talked about it. Your life is complete. There's our mean listed as a mu. Okay, so all of these values are different things that you might see reported. And what we're going to do is we're going to get into some kind of nitty gritty stuff when we get to Friday's lecture, and also probably extend into Monday's lecture. Keep in mind, I'm pretty sure you guys have an exam coming up on Wednesday. One of the things that I noticed about the last exam, some people just like flew through it and then submitted it. Don't do that, right? You are allowed to use all of your resources. So anything that I've posted, you absolutely can use. You're not cheating or anything like that. So make sure that you do some studying before the test comes out. But then once the test comes out, take your time. You got a full day to do it. And yeah. So stay tuned for the discrepant event, and I'll talk to you on Friday.
Schriftwäldisch. Die wollt das selber machen, dann direkt auf den Link.